in this module we'll look at two things. First, how to create date or time data in R, and second, how to convert other data types to date or time. Right, now let us begin by creating the date of the last R release of 2019. So that was R 3.6.2. so we'll create that date here in RStudio. Right, so let me put it as a release date, right, and it was 2019 December 12th. Right, so I'll try to save this as the release date. Okay, now let us call this and see what it returns. Right, so we see 1995. Right, so we wanted to store the date as 12th December 2019, but R has stored it as 1995. Right, so why do we see 1995 here? What is actually happening here? Now before we probe further, let us just check the class of this variable. Right, we'll see what class release underscore date belongs to. Okay, it's numeric, right? It's a number. What we wanted was a date, but what we have ended up is with a number. Right, now what is actually happening here is that R has subtracted 12 and 12 from 2019. That is, it has subtracted 24 from 2019 and it is returning 1995. Right, so clearly this method is not the right way to store date or time. Now let us see if we can get some hints from the built-in R functions we used in the previous section. If you observe the output in that module, all of them returned date time wrapped in quotes. Right, so let us now wrap this date in quotes and see what happens. Right, so I'm going to take release underscore date and I will wrap it in quotes. Right, now if you check the class of release date, it is character, and if you call release underscore date, okay, now we can see the date. Right, it is 12th December 2019 as we intended. Now it is not doing any arithmetic, it is not downloading 24 or 12 from 2019, so that's great. But is this the right way or right format to store date or time? Actually no, because the problem is that if date and time is saved as character or string, the nature or type of operations that we'll do on them will not work. Right, now because when you're dealing with date or time, you'd want to add a few days or a few weeks or months or years to that date, or you would want to extract different components from the date or time. Right, so we'll look at that in another module where we learn how to extract date and time components, but you would like to extract the year or the month or the hour or the time zone, something like that. Right, and that is not going to work if you store the date or time as a character or string. Right, so we need to look at some other way of storing this date. Now let us go back to the functions we learned in the previous module. Right, so we looked at sys.date and sys.time, or we looked at today and now from the lubridate package. Right, so let us look at the class to which they belong. Right, so we have looked at what happens when we store it as a number or when we store it as a character or string. Now let us see how the output from those functions, that is built-in R functions, to which class they belong. Right, so let us see to which class sys.date belongs. Okay, so now you see date here. Right, so the built-in R function, they have a different class, and we will learn about this class in this module. But there are a couple of other classes as well. Right, so let us see to which class the now function from lubridate belongs. Okay, so you can see POSIX CT and POSIX T. Okay, obviously what is this POSIX thing here? We'll come to that in a bit. But now you know there are other ways or other classes using which date and time can be stored in R, right? So that is what we'll do in this module. We'll look at three different classes. The first one is date, the second one is POSIX CT, and the third one is POSIX LT. Now I'll come to what this POSIX thing here is and what do CT and LT stand for. If you're curious, CT stands for calendar time and LT stands for local time. But we'll explore each of these classes one by one, right? We'll start with date, then we'll understand what the POSIX thing is, right? Then we'll look at POSIX CT and POSIX LT and when to use each of these different classes, right? Which class is the right one to use at which time or for which purpose, right? We'll look at that as well. Right, so now let us start with the date class, right? The date class represents calendar dates, okay? It should be used only when you are dealing with dates. If you are dealing with date and time, then you can't use the date class. The data that you are dealing with should only have the date component. It should not have any time component or time zone in it, okay? So the first thing to remember, use the date class when you're dealing only with dates. Now before we use this class for the date which we are dealing with, which is 12th December 2019, let us also understand how R stores these dates internally, right? So how is R dealing with these date and time internally, right? So for that what we'll do is we'll use the unclass function, okay, and pass sys.date. Let me clean up the screen here, the console. Okay. All right. So now you're seeing a number here, right? So before we said that we should not use numbers to store date or time, and now we can see that internally R is using a number to store this date, right? And the number is 18363. So what does this number represent, right? Why has R stored the date as a number or integer? Okay, before we answer this question, we need to know something else. In R, dates are represented as the number of days since 1st January 1970. Okay, that is the origin for date and time in R. Now for that, if you see this here, lubridate has this origin component and it returns the same thing, right? 1st January 1970 UTC, right? So all dates in R are internally stored as the number of days since 1st January 1970. So the date which we are dealing with right now, right? So the current date is 11th April 2020, right? So internally R has stored this as 18,363 days since 1st January 1970. Okay, so what we'll do is now we will store our date, that is the release date of R3.6.2, using the date class, and then again we'll come back to this concept, right? So to store this as a object of date class, we'll use the as.date function, as.date, and then within quotes 2019 12 12, that is 12th December 2019, right? Now if we check the class of release underscore date, it will be date, right? So we have learned how to store our date, the date which we are dealing with, as an object of the date class, right? Now let me come back to this uh, origin concept here, right? The origin is 1st January 1970, and we said that R stores all the dates as number of days since 1st January 1970. Right now, if you unclass this date, this release underscore date, you'll see a number, right? That is how R would have internally stored this particular date. 12 December 2019 is stored as 18,242 days since 1st January 1970. Now you can get the same number in another way, right? Release underscore date and then subtract this date, which is the origin, and that is 1970 1st January, right? So you can see the output is time difference of 18,242 days, right? So I'm spending a lot of time on this so that you understand internally how R is storing the date, right? It stores the date as the number of days since 1st January 1970, right? And we also looked at the first date time class, that is date class, and you can create an object of date class using the as.date function. Now, once you do this, you can do a lot of date arithmetic, that is you can add and subtract days, months or years from this, and you can also extract different components from the date, right? So we'll come to that in a different module. Right now the focus is on understanding these three different classes. Now from this example, we know that dates are internally stored as number of days since 1st January 1970. Now what about dates older than the origin, right? So we are saying the origin for dates here is 1st January 1970. What about a date that is older than this 1970? If it comes before, let us say it comes in the 1960s or 1950s, how are they stored, right? So let us take this date and see how it is stored, right? So I'm going to use the date just 1963 08 28, that is 28th August 1963, right? So if I look at how this is internally stored, then you can see 2318, but there is a minus symbol before that, right? So dates older than the origin are stored as negative integers, right? So dates that come after the origin, that is dates after or from 1st January 1970, are stored as positive integers, and those dates which come before 1st January 1970 are stored as negative integers, right? Now for those who are not aware, this date we have chosen because this is the date on which Martin Luther King Jr. delivered his famous "I Have a Dream" speech, right? So that was delivered on 28th August 1963, right? So good. We also learned how to store a date or time data using the as.date function. We understood how R internally stores these dates, and we also learned the date on which Martin Luther King Jr. delivered his famous "I Have a Dream" speech, right? So now let us move on and we learn how to convert numbers into dates, right? So now we learned how to convert a string or character data into the date class, right? So here we enclosed the date in quotes and then we passed it on to the as.date function, and it was saved as an object of date class. Now if we have numbers, how do we deal with them, right? So now we'll move on to that topic and we'll learn how to convert numbers into dates. Now the as.date function can be used to convert any of the following to a date object, right? It can be a character or string, it can be a number, or it can be a categorical or qualitative data, right? So now we have seen how to convert characters or string to a date, and now we'll see how we can use the same function to convert a number to a date, right? So let us see how to do that, right? We'll create the same date, that is 2019 December 12th, but we'll use a different input. Okay, so here we are convert number to date. Okay, so we'll use as dot date. So when we're using a number, how does R make sense of this, right? Can we just give the number and will R actually figure out what the date is, or should we also specify the origin that has to be taken into account for creating the date, right? So we saw here we have an origin, right, which is 1st January 1970. So when we give a number, does R use this origin and calculate the date, or should we also specify the origin as well, right? We'll look at that, right? So here we saw that internally R stores the release date as 18242, that is 18,242 days from or since 1st January 1970. So let us just give this number and see what happens, right? Either we'll get a date or we'll get an error, right? So there is a error and it says origin must be supplied. So R is not going to use this origin by default. You have to specify the origin. So when you are giving a date, when a date object is being created, R will use the date which is 1st January 1970 as the origin when it is internally storing that date. But when you are trying to create a date by supplying a number, then you have to specify the origin as well, right? So we'll specify the same origin that we have here, which is 1st January 1970, right? So we have the date here, right? 12th December 2019, right? So you have the number and then you specify the origin as well, and based on that R will create the date. Now how about changing this origin, right? Let us say we want to change the origin to 1st January 2000 instead of 1st January 1970. You want to use a different origin, then you have to change the number as well. If you want the same date, then you have to change the number as well, and that number would be 7285. That is 12th December 2019 is it comes after 7,285 days from 1st January 2000, right? So I'll put it down here, it will be more clear. The origin is 1st January 2000 and the date is 2019 December 12th, right? So whenever you're trying to create the date by supplying a number, do specify the origin as well. And this origin, unlike what R does when it stores the numbers, when it stores the date internally, this origin is something that you can specify, right? So here in the first example, we specified the origin as 1st January 1970, and in the second case, we specified the origin as 1st January 2000, and accordingly we also changed the number that we have specified there to get the same date, right? So now you know how to create dates from both string data as well as from numbers, right? And we have also understood the date class. Now before we move on to the POSIX CT and POSIX LT classes, we'll quickly take a look at the ISO 8601 standard for representing date and time in R. Okay, so I'll clean up the screen here. Let us go back to the slides. Okay, here is the ISO 8601 standard, right? And if you have carefully observed, the format in which we have been specifying the dates as well as of those returned by functions such as sys.date or the now function or the today function is the same, right? It starts with the year, right, and the 4 digits for the year, and then followed by the month. Again, it has 2 digits, followed by the day. Okay, so the date component has the year in 4 digits, the month and day in 2 digits. Then it is followed by the time component, which is the hour, minute, second, and some cases you will see the milliseconds as well, and finally the time zone offset. Okay, I'll come to this part in the after a couple of modules, right? I'll come to the time zone and offset part when we come to the module on time zones and daylight savings. But largely this is the format in which you will see date and time in R, right? First the date component with the year followed by month and day, then the time component where the hour is followed by the minute and second, and finally you'll see the time zone or the time zone offset. Now let us use a different function to create the same date which we have been dealing with, but in this format, right? ISO 8601 standard, and we'll use a different function as well. Now another thing that you have to keep in mind is this, that this standard is the internationally accepted way to represent dates and times, and it uses the 24-hour clock system. Okay, so let us go back to RStudio. Here we'll deal with the ISO 8601 standard, right? And we are going to use a function called ISO date. Okay, so here we'll not use numbers, or we'll not use the character or string data. Instead we'll specify each component of the date and time, right? Starting with year, which is 2019, followed by the month, which is December. Okay, then followed by the day, which is again 12. This is followed by the hour, which is 8. Okay, so far I did not mention the time component of this release date, but here we'll add it. The minute is 5, the second is 3, and the time zone is UTC, right? So here we are specifying each component of the date, time and the time zone, right? Now let us create this, right? So you can see the output here, right? 12th December 2019, and the time of release was 8 hours 5 minutes and 3 seconds, and the time zone was UTC. Right now, in the 5th module, we'll look at all the different weird ways in which date, time are specified in the real world, right? So we'll look at that in the date and time formats module. But for the time being, let us get back to the different date and time classes that we are exploring, right? And we'll now look at the POSIX CT and POSIX LT classes. Now I'm sure you must be wondering what this POSIX thing is, right? So POSIX stands for Portable Operating System Interface, right? It's Portable Operating System Interface, and it is a family of standards specified for maintaining compatibility between different operating systems. Okay, it's a family of standards specified for maintaining compatibility between different operating systems. Now before we learn to create POSIX objects, let us go back and look at the now function from lubridate, right? So here I'll put it off as POSIX, right? And if you look at the class of the now function, right, it returns POSIX CT and POSIX T. right? This because the now function returns the current date time as a POSIX CT object. Now let us look at the internal representation using the unclass function, like how we did for the date class. We'll look at the internal representation of how the date and time are being stored, right? So I'll go here and I'll do unclass, and you see a big number here, right? It's large number. In the previous case we were seeing it in thousands, but now this is a really big number. Take a minute and try to guess what it is. Okay, so this large number is the number of seconds since 1st January 1970. In the previous case, we looked at the internal representation for the date class as the number of days since 1st January 1970, right? That was for the date class. Now for the POSIX CT class, the date and time are internally stored as the number of seconds since 1st January 1970. Okay, so there it was days, here it is the number of seconds. Okay, and CT in the POSIX CT stands for calendar time, right? So now we'll store our date as a POSIX CT object, right? And for that we'll use as dot POSIX CT, and here within codes we'll specify the date component as well as the time component, right? So remember in the previous case when we were using the date class, we only specified the date component, right? We did not specify the time component because the date class is there to store only dates. But the moment your data includes the time component as well, then you have to move out from the date object, and then you need to think whether you want to use the POSIX CT class or the POSIX LT class. Okay, so for the time being, since we are looking at the POSIX CT class, we'll use that to store the date, right? So here you can see 12 December 2019, the date is there. The only thing is the time zone, it is using the current time zone. So since we are based out of India, it is using the Indian Standard Time, right? And if we unclass this date as well, let me store this as the release date. So we'll move out of the date class. Now we'll use the POSIX CT class, and if I unclass this, then you'll see the number of seconds since 1st January 1970, right? Great. So now we know that when we have the time component also included in our data, we'll not use the date class, but we'll use the POSIX CT class. Then what about POSIX LT, right? So there are two classes within this POSIX thing. The first one is POSIX CT and POSIX LT. Like I said, CT stands for calendar time and LT stands for local time. So we'll learn the POSIX LT class, okay, and then we'll understand when we'll use POSIX CT or the POSIX LT class, when to choose between these two. Now the POSIX LT class, right, represents the same information, right? The information that we are looking at here, which is the date component, the time component, and the time zone. The same thing is represented but in a list, right? So you can it stores the second, the minute, the hour, the day of the month, year, and then there are additional information, right? The day of the week, day of year, the daylight saving time flag, so the daylight saving is in effect. Then it stores the time zone and offset in seconds from GMT, right? And so apart from the date and time component, it also stores the day of the week and day of the year, right? So W day here stands for day of the week, Y day stands for day of the year, M day is as usual the day of the month. And apart from that, it also stores the offset in seconds from GMT. That is the last one that you're seeing, GMT off. Right, now what we'll do is we'll store the release date of 3.6.2 using the POSIX LT class, and then we'll see all these information being stored in the underlying list, right? So let us go to RStudio here. Now I'll store the release date as POSIX LT. Use the as.POSIX LT class or function, and then we'll store the same information, right? 2019 December 12 in the hour, minute and second component. Right, let us call this, right? So you can see the date and time here. Now, like I said earlier, POSIX LT stores date or time components in a list, and these can be extracted, right? So let us look at the date time components returned by POSIX LT. So I'll now run this through unclass. Right, so here you can see all the different components, right? The second, minute, hour, the day of the month, which is 12th, the month, here it shows us 11, right? Here you can see this MON stands for month, but it shows 11, and here we have 12. The reason is the counting starts from 0, right? So January is 0 and December is 11. That is why you see 11 here. And then year is 119, right? So we have 2019 is the year, but here it shows 119. The reason is this is number of years from 1900, right? That is what it is, years since 1900. And 2019 is 119 years from 1900. That is why you see 119 here. And then the weekday is 4, the day of the year is 345, that is the 345th day of that year. Daylight savings on is 0, it says no daylight savings here, it's not in effect. The time zone, it is giving IST, based out of India, so the time zone here is Indian Standard Time, and offset in seconds from GMT, it shows NA. So I'll come to this part, I'll come to the daylight savings time zone and the offset in seconds from GMT in the fourth module, right? So when we look at daylight savings and time zones and other things, we'll look at this in more detail, right? Now if you want all of these as a list, then you can use the unlist function, right? So it will return all of them as a vector, right? All the same information, it is here returning as a vector, right? Great. And you can also extract different components from this class here, right? So if I look at extract components, can do that using the dollar symbol, right? Let us say we want to extract the hour component, right? You can see 8 here. If you want to extract the month component, and use MON, and you can see 11 here. Like I said, the month starts from 0 to 11. 0 is for January and 11 is for December, right? So POSIX LT stores date and time as a list internally, so you can always extract all these different components that we looked at just now. You can extract them, right? I'll take you through the components once again. The first one is second, the second one is minute, followed by hour of the day, then month of the year, it goes from 0 to 11. Then you have the time zone, day of the week, day of the month, year is year since 1900, Y day is day of the year. Then you have daylight saving flag, and then offset in seconds from GMT, right? So great. We'll end this section with a few tips, suggestions on when to use the date class of the POSIX CT or LT class. Now, use the date class when there is no time component. Only you have the date component, then you use the date class. When you're dealing with time and time zones, then you can use the POSIX classes, that is POSIX CT or POSIX LT. Now, between these two, if you want to access or extract the different time components, then use POSIX LT, right? Because it stores the information as a list and you can access or extract them. So between POSIX CT and POSIX LT, if you want to choose, use POSIX LT when you want to access or extract the different components. And when there is no time or time zone component, use the date class. When you're dealing only with the date component, use the date class, right? Now a few practice questions for you. The R release of 1.2.0, right, was on 9th February 2000, right? Now we want you to save this date and time as date class using as.date, and then also as a date class, but instead of using the date and time component as character or string, use the origin and specify the number of days, supply the number of days, then store it as a POSIX CT class, and then as POSIX LT, and extract the day of the month, day of the year, the month, and the time zone. Okay, so you'll store it as POSIX LT and extract these 3 or 4 different components, and finally you'll use the ISO date function and store this date, right? You'll specify each of the components separately, that is the year, month, day, and the time, hour, minute and second, and the time zone. You'll specify all of them separately and you will store it, right? So again, all these is mentioned in a PDF file in this module, and we've also given the solution, the R script, which contains the solution. So try this first, refer back to the functions we have used, try it, and then compare your solutions with the ones that we have given you. Right now we'll move on to the next module, where we learn a bit about date arithmetic. That is, we'll learn how to add or subtract days, weeks or months from a date, right? And here we'll be using these classes that we just learned, that is as.date and the POSIX CT and LT classes.
I hope you have enjoyed listening to this video. Please be kind enough to like, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos on our playlist, and subscribe to Rsquared Academy channel to learn more. Happy learning!